A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, instructor for the NPTEL MOOC course, Pavement Construction and Technology, funded by Ministry of Education, Government of India. Our today's lecture under the module 12, where we will be discussing the full depth reclamation along with the discussion on the cold in place recycling and cold in plant recycling, and we will discuss also some aspects related to the cold mix design. So, at the very beginning, I would like to acknowledge the use of text, informations, graphs and images sourced from various textbooks, codal standards, general articles, reports, newsletters and public domain searches. Now, as we discussed in our previous lectures about the recycling of the bituminous pavements, where we specifically discussed about the hot in plant recycling and the hot in place recycling. In today's lecture, I will be covering three more aspects related to recycling, and where we will discuss cold in plant recycling. We will simultaneously discuss also the equipments which are involved in all these three processes. So, cold in plant recycling, cold in place recycling and full depth reclamation. In addition to this particular one, we will briefly discuss about the design of the cold asphalt recycled mixes also. So, as the word itself says cold, that means there is no heating which is involved in this particular one. So, cold recycling involves the reuse of the existing pavement materials without the application of the heat, and as in the case of hot mix recycling, when we talk about cold in plant, that means it is the recycled mix is produced at plant. When it is in field or in situ, it is cold in place recycling. Now, there is no a small difference which exists between full depth reclamation. It is also similar to an in situ cold recycling, but with some specific considerations that we will discuss in the, but both full depth reclamation and cold in place recycling are the recyclings which are done in situ. So, the cold recycling is mainly attempted in three ways: cold in plant recycling, cold in place recycling and the full depth reclamation. Both cold in place recycling and full depth reclamation are in situ recycling. Now, as the term itself says, cold mix asphalt recycling is the process of reuse, as in the case of hot mix recycling also, of reusing the reclaimed asphalt pavement by blending it with new binder, recycling agents specifically, or virgin aggregates if required, to produce cold mix. And it says base materials. Most of the time the recycled mix which is produced through cold mix recycling is preferred to be used as base courses. So, that means after the construction of the base course, one need to definitely required to go with an overlay of a wearing course, a bituminous overlay over it. So, the process can be carried out either in place, in situ, which is your cold in place recycling and full depth reclamation, or at a central plant mixing plant, which is your cold in plant recycling. So, first coming, cold mix asphalt recycling is usually applied. What kind of distresses can be applied? The wonderful part is a significant number of distresses can be addressed specifically with cold mix asphalt recycling. So, is usually applied to address pavement distresses affecting both surface and base courses. So, you can go for a greater depth, specifically the bituminous wearing course, surface course, or the bituminous binder and the base courses can be any issues related to these bounded courses can be addressed in this one, though its use has been more prevalent for base course rehabilitation, because mainly if there is some issue specifically with the bound bituminous courses, then they can be addressed with the cold mix asphalt recycling. The process typically stabilizes the reclaimed materials, with, and since it is a cold mix technology, so the recycling agents which are going to be used are either a foamed bitumen or an emulsified bitumen, and may include, and in certain cases we go for certain additives also. The additives may be, or many a times they are called as active fillers also. So, the additives are lime, fly ash or cement. These are the common additives which are specifically used, and the purpose of using these additives is to improve the strength and the durability of the cold asphalt recycled mixes. These cold mix asphalt recycling is quite effective to address surface distresses which are maybe in the form of cracking, rutting and poor ride quality. So, they can be addressed with the help of cold mix asphalt recycling, while offering the key advantages of enhancing pavement structure without altering its existing geometry. This is what a conventional advantage which is there with the recycling of the asphalt pavements. Now, let us first go with the cold in plant recycling CIP. In cold in plant recycling, the reclaimed bituminous material is transported to a mobile cold mixing plant. So, the amount of RAP which is generated, if there is presently no facility to go for in situ one, or the amount of reclaimed material is more than what can be used. So, a good amount of reclaimed material will be stockpiled at the plants, some nearby plants. So, this is usually the cold in plant recycling will be preferred. Either you do not have facility for in place recycling, or the amount of the bituminous bound materials which are produced are large and of good quality, they are stockpiled at a mixing plant. And then this cold in plant recycling attempts the recycling using specifically the either the foamed bitumen or emulsified bitumen as a recycling agent. And here, as we know, since it is a plant production, so the plant precisely measures and feeds the reclaimed bituminous material and fresh aggregates, usually in the twin shaft pug mill mixer which is there. You can see this is how this is a twin shaft pug mill mixer specifically at a cold mix plant. So, a metered amount, the important aspect in this one also is a metered amount of either bitumen emulsion. These two common recycling agents are bitumen emulsion or foamed bitumen, which are preferred is then injected in this particular one. After being mixed for a specific duration to achieve a homogeneous blend, the material is then transported to the work site, paved and compacted, as we do in case of hot mix asphalt also. Mixing process for cold mix recycling can be carried out either a batch plant, drum plant, or a continuous stabilizing type plant which is there, which is highly preferred specifically for the production of these cold recycled asphalt mixes. Now, the key steps, if we can put up those key steps in sequence, the first is the removal of the existing pavement. So, this is the your ripping is there or your milling is there, ripping is there, then crushing has to be there, or milling or pulverization has to be there, or milling has to be there. So, the removal of the existing pavement has to be there. Crushing and stockpiling, because the sizes, if the sizes are more than what can be accommodated, usually we go for sizes up to 2 inches. So, if the sizes are more of your reclaimed bituminous material, then it needs to be crushed, and finally, you stockpile it at a mix plant. Then the mixing is there using your different recycling agents, emulsified bitumen or a foamed bitumen. Lay down, since it is an emulsion, there may be a requirement for aeration which is there. So, that and thereafter the compaction and curing requirements will be there. So, these are some specific requirements. We will discuss these requirements in upcoming slides also. And finally, since it is laid as a base course, so on the top of it you need to go for a bituminous wearing course. So, if we look into the aspects specifically cold in plant recycling about the mixing part, then in cold in plant recycling, precise control of mixing time is important, because what happens if I am using, say, the emulsified bitumen, if it is mixed for a longer period of time, then the breaking of the emulsion may takes place. So, this may again will make your mix very stiff, and or if the time is given less, then the proper coating may not take place. So, the control time is very important at the plant also, because as mentioned, over mixing can cause premature breaking of emulsified bitumen. So, then your mix will become stiff enough and very difficult, or it may not be feasible to compact it in the field. While under mixing may lead to inadequate coating of the aggregate, so you will not have a good cohesion of the mix. For foamed bitumen, The foaming is done at the plant itself. So, you have we will discuss about the foaming aspects also when we will discuss the mixed design aspects. So, foaming is done at the plant itself, and it can be done at in situ also, where you have a bitumen tanker, you have a water, and then hot bitumen is injected in the bitumen foamer. Along with it, the cold water is injected, which leads to the foaming of the bitumen. Now, here the important is the injection rates of the hot bitumen. So, it may be the grade of the bitumen, the temperature of the bitumen, and this is the source of the bitumen has to be there, and water, how much percentage is to be injected, that is an important aspect which will control how much amount of, because this foaming exercise increases the volume of your bitumen. Now, how much, as the volume increases, the viscosity decreases, it helps us to coat your aggregates in a better manner, and along with it, because in due course of time this volume will fall down. So, we need to know the another aspect is the half life. By the time this volume, whatever the volume which has been expended gets reduced to half of its initial volume. So, these are some important characteristics which needs to be understood when we are using foamed bitumen in case of cold in plant recycling also. So, the injection rates of hot bitumen and water must be carefully regulated to ensure uniform coating of the aggregates. Laydown, aeration and compaction. As I mentioned, aeration of the recycled mix is essential to reduce excess moisture, because even when we are using the reclaimed bituminous material, many times you need to add, when you are producing these cold in plant recycled mixes with your emulsified bitumen, you go for adding some initial water to the wrap so as to improve its workability. So, and there may be some initial moisture content already existing in the wrap. So, the moisture content of the wrap needs to be first determined and then monitored at the hot mix plant. Sorry, specifically here it is a cold in plant because there is no heating involved, to reduce excess moisture and volatile content, thereby improving stability before compaction. So, this is, you need to here you can see the mix is placed in windrows and it has been leveled with the help of a motor grader. So, it is going to be brought to the camber by using this, or the cross profile using this motor grader. So, the mix may be placed in a windrow and leveled to the required cross slope with the help of a motor grader, and this process also helps us to do some aeration to a certain extent, and this process helps to reduce the fluid content, making mix stable enough to support the compaction equipment, and then your standard compaction equipments, which are vibratory rollers or your specifically the sheep foot or ped foot rollers, which are used for compaction of these stabilized courses. Now, at central in plant, the cold recycled mix is produced using either bitumen emulsion or foamed bitumen followed by laying and compaction, but there are few typical advantages which are specifically available with in plant recycling. There are certain cost aspects also, because you can understand the reclaimed material has to be brought to the plant, and then the mix has to be produced at plant and again need to be transported to the site. So, these are some certain cost related aspects which gets introduced when you are doing cold in plant recycling, but some important aspects which are there, through this particular one you can go for large amount of production, specifically when you are producing cold in plant recycled mixes. Quality control, because at a plant you have a good control over the injection of your emulsified bitumen or your foamed bitumen or the other additives which are required, maybe in terms of your cement or lime. So, and at the plant when you are mixing it, the control over the mixing is also better compared to what can be there in the case of field. So, allows for precise control over input materials and mixing, ensuring consistency quality. This is one key important advantage which is there with cold in plant recycling. Stockpiling treated materials, specifically in the case of foamed bitumen, can be stockpiled for some time for use at a after later period. Central plant recycling is preferred when stockpiles are already available. So, you have already some wrap available with you which is lying unutilized, then definitely cold in plant recycling will be a good option. And when the existing pavement must be removed from the site and in place recycling is not a viable option. So that, because if say suppose all your bituminous courses have shown some amount of distresses, then the entire one has to be removed, and that may not be possible with your in situ cold in situ recycling or in place recycling. So that has to be brought to the plant and then you produce it to come up with the cold in plant recycled mixes. The second, the word itself says, is cold in place recycling, when you do the recycling at the in situ itself, at the site itself. So cold in place recycling is a pavement rehabilitation technique that reuses existing materials directly on the site. So you don't have to bring your reclaimed asphalt materials to the plant, it is directly used at the site. So you may have one single equipment, or there may be a train of set of equipments which may be used as there it was in the case of the hot in place recycling also, but there is no heating which is involved here. So the process involves simultaneously milling and mixing. You are milling, you are removing the existing surface, you are mixing it with a recycling agent, you are mixing it with some any other aggregates, virgin aggregates which are if the gradation is falling short at certain sizes, and in addition to the stabilizing additives carried out using either a single machine or a train of equipment. As I mentioned, since when it is carried out at site, it may be a single machine or a set of equipments forming a train of equipments. So the milled material is conveyed to a pug mill. Whatever is milled is conveyed. If required, it needs to be brought down to it needs to be sieved so as to ensure that the sizes are within acceptable ranges, which also receives fresh aggregates through a parallel supply. In addition, as I mentioned, if some aggregates are also required, then a parallel supply line is there to give you the fresh aggregates also, and separate feeds for your recycling agent. Now, when it comes for foamed bitumen specifically, dedicated lines supply hot bitumen and water, as I mentioned, because foaming is to be done at in situ itself. So there will be definitely separate supply lines for your hot bitumen. The hot bitumen is typically in the range from maybe in the range of 160 degrees centigrade to up to 200 degrees centigrade, and then the water needs to be injected to generate foam before it is introduced in the pug mill. So first the foaming have to be done, and then this foamed bitumen is to be introduced to the pug mill. The prepared cold recycled mix is discharged directly into the paver hopper. So finally it comes out through the paver hopper. So we have the vibratory screeds are there, followed by paving and compaction, and then it is spread to the desired cross profile and compacted. Cold in place recycling efficiently restores old pavements by correcting the profile. This helps us to correct the profile also. It helps to address the wheel ruts also, when these wheel ruts are because of your base courses, bound base courses. Re-establishing the crown and cross slope, eliminating the potholes, unevenness and the roughness. It also addresses transverse, reflective and longitudinal cracking. So cold in place, because we are going up to the and specifically when it is cold in place recycling, typically we go for a thickness up to around in the range of 75 mm to 100 mm. So this is cold in place recycling, many a times is called as a partial depth recycling under the category of cold in place. When the depth is more than that, specifically if the depth is say around 75 to 100 mm, then it is called as a partial depth cold in place recycling. When the depth is typically ranging say from 100 to 300 mm, that means we are going deep. We are going up to the unbound courses also, which may be your granular base courses, wet mix macadam may be there, or the granular sub base courses are there. When we are going deep into those layers up to the depth of 100 to 300 mm, then this becomes your full depth reclamation. which again we are going to discuss after. So both are cold in place recycling, but the one which is attempted in the depth ranges from up to 75 to 100 mm comes under the category of cold in place recycling, and when the depth goes lower down, specifically to the unbound courses of your unbound base courses or sub base courses, we call it as full depth reclamation. Now, typical components which are involved in cold in place recycling plant or a recycler, this is a component you can see in this particular, we can try to understand this particular one. This is a recycler. So, you have the milling drum which is going. So, this one is a showing where you can go for a greater depths also. This one is a typical one where you can see it is written as unbound pavement also, bound pavement also. So, it can mill to greater depth, but when we are going for cold in place recycling, definitely the depth will be not more than 100 mm. So, typically it will be restricted to your bituminous bound courses. So, I can say this is a bituminous wearing course, there may be a bituminous base course or a binder course may be there. So, that these two are, this milling drum is going to remove this particular one. Finally, in this milled material, you will have the injection of emulsion or the injection of the foamed bitumen also, along with any additives, and this is the mixer which, so it mixes definite period of time and then it comes out. Here you have the tamping screed which is there, then vibration is there. So, finally, this is your stabilized material which is there, which is compacted to a certain extent by your vibrating screed, and then it is ready for your rolling or compaction operations. So, similarly, here you can see this is a train of this particular one is shown where a water is there. Water is required when you are using emulsified bitumen, is requirement is there. You have the milling machine is there. So, then you have the recycling unit where the conveyor belt is there. This is the one which is conveying the reclaimed material, and then screening and crusher is there. If there is a oversized material is there, then it will be removed, or the bigger ones can be reduced down, and finally it is to be mixed and it comes out. And here you can see this is an emulsion tanker which is there. So, you can have one equipment, one big equipment or a set of equipments running like a train is there. So, what are the main components or the main steps which are there specifically in cold in place recycling is first the cold milling unit to remove the existing pavement surface. Then the material transfer, as you can see this is a conveyor belt, the conveyor system to carry milled material, and if required the fresh aggregates will be simultaneously added. So, precise proportioning, precise weighing and proportioning of different aggregate sizes, as I mentioned, typically we usually go for sizes up to 2 inches, 40 mm to 50 mm. So, whatever oversizes are there, they are discarded. Mixing pug mill equipped with separate feed lines for aggregates and recycling agent, as recycling agent can be an emulsified bitumen. In case of emulsified bitumen, you need to ensure that the wrap is having a particular amount of moisture content, because that is required for a good workability of the wrap. This is when you are using emulsified bitumen as this recycling agent. Then finally, once this it is mixed with a foamed bitumen or a emulsified bitumen, then it comes out through with the help of these vibrating screeds. These are tamped and profiled the recycled mix to your desired profile. Then with the set of equipments it is compacted, and in this particular train you need to have a proper control, specifically the dust emissions which are there, because during the reclaiming of the existing pavement a lot of dust gets generated, and a control of there should be there for the noise also. Now comes the other part, which is full depth reclamation. As I mentioned, this is the one where you go for greater depths in the ranges of 100 to 300 mm. So, if there are certain distresses which are taking place because of underlying courses, that may be your unbound base courses are showing some distresses, or unbound your granular sub base courses are showing some distresses. So, in that case we can go for a greater depth, and we can this particular one can be recycled to produce a stabilized base course. So, this is an advantage here in this full depth reclamation, that in addition to the bound courses, we are going to address any issues which are there with the unbound courses, and then these unbound and bound courses together will be with, whether along with a requirement of virgin aggregates or not, along with and the recycling agents will be used to produce a stabilized base course. So, full depth reclamation is a cold recycling technique in which all asphalt layers and the part of the underlying unbound layer are reclaimed and stabilized to form a new base course. This is what this specific thing is there. It is usually recommended for pavements with severe distresses when you have deep ruts, that is, and the lower layers are the one which are contributing to these distresses. If the distress is because of your unbound courses, then deep rutting is there, load related cracking is there, reflection cracking is there, extensive patching is there. We need to go down in that case, base and subgrade deficiencies are there. So, then you will prepare a good stabilized base course so as to strengthen your pavement structure. So, the key advantages usually associated with full depth reclamation is improves pavement structure without altering this geometry, because you are treating that particular unbound and bound course to produce a more stabilized or a more stronger base course. So, overall your pavement structure is not getting disturbed much, only on the top of it you will require a wearing course. Restores profiles, crown, slope and eliminates ruts, potholes and irregularities. So, most of the distresses can be addressed through this full depth reclamation. Accommodates pavement widening. This is another concern, because when you are widening it, you are going to match the existing one with the widening one. So, you may have to require that your base course are coming up in profile, your unbound or bound base courses are in profile of the widening one, also existing one. So, in that case you need to strengthen the existing one. So, full depth reclamation can be a good option. Provides a uniform and durable pavement structure, because this is a controlled process. So, you get a good uniform strengthened base course. Eliminates major cracking, improving ride quality. Reduces frost susceptibility with suitable additives, because if some of the materials are there, specifically your unbound courses, granular courses materials are there which may be more susceptible, specifically which are highly clay with high plasticity index values. So, those kind of materials, in that case they can be stabilized using the additives like slime, which can be used to stabilize those weaker materials. Low production cost, usually need only a thin wearing course, because this gives you a very strong base course. So, on the top of it usually you go for a thin wearing course. So, what are the typical components which are involved specifically in full depth reclamation is pulverization. So, it is the breaking. Now, because you are going to a greater depth, you can see here is this particular depth is there. So, you are going for a greater depth, you are going for a depth where these are the asphalt courses and these are your unbound courses. So, you may be going for a greater depth in this case. So, pulverization, to break down to this material to the required sizes, addition of recycling additives, slow shaping of the mixed material, it has to be brought to the profile and the camber, compaction, and on the top you need to go for an asphalt wearing course. This is the usual process, and this you can see a set of equipment working, and finally you are coming up with this stabilized base course. So, in full depth reclamation, recycling is typically carried out to a depth ranging from 100 to 300 mm, and what we have usually in this particular one, we have a self-propelled high horsepower reclaimer, because you are going for a depth of around 300 mm. So, a high power reclaimer is required. A motor grader is required to spread it to the desired camber, and then heavy rollers, because the thickness is high enough in that case. So, going through these individual steps, pulverization is the process usually performed with cutting drum, and the specific motion which is used is the upcut method. You can see in this particular one that whenever this one is going, this drum moves in this manner. So, it goes from your unbound courses and then removes your bound courses. This is a typical way in which this existing road material is removed, and why it helps to cool down the tool when it goes into the unbound courses, minimizes wear and enables effective milling through the moist layers like wet mix macadam or the granular sub-base course. So, when it goes into these underlying layers, it gets cooled down. So, and then it removes this bituminous material. So, this is the upcut method which is usually used in the removal of the existing pavement or the pulverization which is there. While breaking the asphalt layers from the bottom upwards, so this is one way. You can use rippers also, and then hammer mills are also there. These rippers can be attached with your graders also, with dozers also. It can break the existing pavement structure, and then through the hammer mills and crushers you need to reduce them to the usable sizes. Application of a stabilizing or a recycling additive is there. Additives like specifically emulsified bitumen, foamed bitumen, cement and lime are incorporated into the reclaimed material to improve the strength and durability, producing a uniform base for construction. So, in this one typically we prefer to go for use of foamed bitumen, because this again the foamed bitumen can be produced at in situ itself. So, here this is a generating system with heated bitumen and binder, so as to adjust the doses of applications, and whatever the virgin aggregates or any other additives specifically to treat the unbound materials, if required in terms of lime or in terms of the two most common materials which are used are lime and the cement. So, whatever virgin aggregates or the lime or the cement which are required to be added to this particular one is spread in front of this reclaimer. So, when it picks up, the desired quantity is spread on the surface in front of these reclaimer. So, it picks up, and then the new materials along with this particular one are mixed together. So, additional required aggregates can be placed ahead of the recycling train to modify the layer thickness or wrap gradation, and dry agents such as lime and cement are also pre-applied. So, this is what is done. Then shaping of the material, because many of them are having the screeds which can lay down to the desired profile, or we can have these motor graders can be used to bring those materials in windrows to the desired shape and the cross slope. So, shaping of the mixed material, when emulsified bitumen is used, bitumen tanker is included in because the emulsion tanker, along with it a water tanker, as I mentioned in case of emulsions, you need to have some pre-moisture content over the wrap for better workability. So, that is taken care during the mixed design of cold recycled mixes, which we will discuss in the next lecture. So, in the FDR train is there, a bitumen tanker is there, along with a water tanker is there to premix, and if already existing wrap is having that required amount of water content, then you do not need to have this an additional tanker which is required. If the reclaimed material exceeds the optimum moisture content, there may be a situation when it is having moisture content more than what is required. So, in that particular case, the motor grader may have to aerate that particular one also. It is helped to aerate it through its blade, and finally, so as to reach the desired consistency where it can be compacted. So, this is how it can aerate also, it can bring it to the desired profile also. And then compaction, large heavy rollers are typically used to achieve the required density of the reclaimed material, and as mentioned earlier, because we typically go for depths of 100 to 300 mm. So, heavy rollers are required depending upon site conditions. Pneumatic vibratory rollers, vibratory pad foot rollers can be employed for effective compaction of the stabilized courses, and you can see this is how it looks like when you have reclaimed the existing surface to produce a stabilized base course. So, this is what we discussed specifically for the cold in plant recycling, and the other one is cold in situ recycling, where when the depth is less we specifically called it a cold in place recycling, and when the depths are more than 100 mm can go up to 300, approximately 300, then we call it as the full depth reclamation. So, compaction, as mentioned, that it has to be done just after the emulsion, and during the compaction part, specifically when emulsions are there, one important concern which is to be taken care is that the compaction has to be completed by the time emulsion starts breaking, because otherwise it will become difficult, the mix will become stiff and difficult to compact. Whereas when you are using foamed bitumen, specifically we prefer that the compaction should be completed by the mix becomes dry enough, because you have the time when this particular one will become stiff. So, we prefer for foamed bitumen one by the time the mix becomes dry, and wherever in case of emulsified one, we prefer to complete it when the emulsion starts breaking by that time. So, curing and application of bituminous wearing course and as there may be various additives like lime or cement may be added. So, these additives may require some additional curing time. So, that needs to be ensured before the same has to be opened up for the traffic. So, proper curing of the stabilized reclaimed materials is essential to achieve the desired strength, prevent raveling. If the traffic is opened before curing, then raveling will take place, and therefore, finally, we allow the traffic once the wearing course is over there. So, traffic is allowed when foamed bitumen stabilized layer until it has dried up, and specifically when the moisture content, we can say for the top 10 centimeter of the layer has reduced to 50% of it. So, these are certain estimates through which we try to work it out. Okay, now this particular one, the moisture content, the surface has become dry enough. So, when the moisture content of the surface has reduced to a certain level, till that time it has to be allowed to dry up. And during this course of time, specifically during daytime, it is always preferred to have light watering over the surface, and this is typically done for at least 3 days, which is there. So, depending upon what type of stabilizing additive you have used, lime, cement and the content, we may have to go for a curing period of a longer duration also, maybe for 1 week. So, the final curing process may take up to a week before the wearing course can be applied. This is very important, otherwise if the proper curing is not done and wearing course is applied, then the wearing course will get damaged, it will get stripped also. So, and your base course didn't achieve the required strength, and after the wearing course, if the traffic is allowed, then immediately this will lead to premature distresses in your these stabilized base courses also. So, the choice of wearing course will depend upon the anticipated traffic load. This is what type of wearing course, it may be a bituminous concrete or it may be a stone matrix asphalt, depending upon your traffic load. So, this is all for this particular talk, where we discussed about the cold in place recycling, cold in plant recycling and full depth reclamation. Next talk we will discuss about the mixed design aspects of cold asphalt recycling. Thank you so much.